For this example, I have a simple box here, and let's see how we can rotate this sphere using matrix transformation. So I will drop down an attribute wrangle from this box, and the function that we want to use is going to be rotate. So if I press F1 and go to this function, we can see that this applies a rotation to the given matrix. And we are going to use this version over here, which takes in a matrix, an amount, and an axis. So back to my wrangle. The first input here will be a matrix, so we want to grab a reference to the matrix of this box as it is right now. And we can go to the attribute wrangle, and for that I will create a variable matrix3m, and I will set this to be equals to ident. So this line will simply grab the matrix information for the object as it is right now. So now I will say I want to rotate this matrix, so m, by an amount. So I will just create a new channel for this, and I'll say ch, and this will be amount. And we have to specify a vector as well, so I'll create a channel vector chv, and this will be axis. Alright, so now we grabbed a reference to the unchanged matrix from the object. We rotate this matrix, and now to apply the matrix to our points, I will say at p multiply equals m. Okay, so now this will apply the new rotated matrix to our points, and I will just create the channels. And for my axis, I will just say 0, 1, 0, so this will now point straight up. And as I increase the amount, we can see our object rotating. One thing to note here is that this, if this axis vector is a normalize, this will also apply scale for our object. So we don't really want that. So then I can just normalize this axis, and I will just say normalize. And now this will always be a value of 1, and we can rotate, and we can change the axis and spin around whatever axis we want. The problem with this method occurs when the object itself is not in the origin of the world. So if I were to move this box away from the center, away from the origin, and then rotate the matrix, we can see that now it doesn't apply it locally, but it applies it in relation to the origin of the world. So you can imagine that this vector, the axis around which the object will spin, is always going to be in the center of the world. So in order to apply this matrix rotation locally to my object, I will first need to move the object to the origin of the world, apply the rotation matrix, and then move it back to where it was. So if I were to drop down a transform node over here, I can say for this transform, I just want to move centroid to origin, and then I apply this matrix, so it's applying it at the center of the world. And I can grab this transform node, and I will hold down Alt and duplicate this and plug this in here, and I will say invert transformation. And if I preview this node now, I can see that the object is where it was originally, and I can increase the amount here, and we can see that this now spins locally. So this order of transformation will come very important later. So just remember that first we have our object or our points, we move it to the center of the scene, to the origin, we apply the matrix rotation, and then we move it back where it was.